All right. Welcome everyone to another Keptn community webinar. Today, the topic is automating quality gates in Azure DevOps with Keptn, obviously. And Bert Van der Heyden, hopefully I pronounced your name correctly.
Something like that, yeah.
Something like that. Now,
you need to polish up your Dutch, yeah.
Yeah, I need to polish up my Dutch, exactly. Hey, Bert, you have been really, fundamental in helping us getting Keptn integrated with Azure DevOps. So first of all, thanks for that.
No problem.
And can you just quickly, tell a couple of words about you, what you do, and why you're actually, interested in Keptn and why you are helping us and contributing to this open source project?
Yeah. So I will pronounce my name first. It's Bert Van der Heyden. So I'm a digital performance consultant at RealDolmen, located in Belgium. So we're a part of the GFI group, and we are a service provider. And yeah, we're doing a lot of things regarding performance, and that's why also in the earlier days, I don't know if people remember, there used to be a product a few years back. It's completely gone now. It was called Dynatrace Admon, and it also had something like some test automation stuff. And also at that moment, and now again, we stay interested in everything that can automate the pipeline, because that's the key, one of the most important parts of our role, and also it helps our customers to really get on that track of that cloud native track and that new software delivery way of working. And there are a lot of challenges, and I think Keptn solves a few. It's not maybe there yet completely, but yeah, I see a lot of potential.
Yeah, so, that's cool. Yeah. And that's why, thank you so much for making these contributions, because people like you help us get closer to where we need to be. Yeah. So the way we are structuring this webinar today, I want to kick it off with a problem statement and kind of how we are solving that problem statement or that problem with Keptn. And then you're going to jump into the demo of actually showing this live in your Azure DevOps environment. And then I think we get a little outlook on what else you've planned. But again, the problem statement is we want to automate build approvals because there's too much manual work being done in approving new builds from different perspectives. And we want to use an SLI, SLO-based Quality Gate approach to actually do this. Now, to kind of bring this a little into perspective, and again, this is something that, Bert, you agreed that this kind of really makes sense, right? What the problem statement in many pipelines, whether this is in our case, obviously Azure DevOps, but it could be any type of pipeline. If you're building, if you're deploying, if you're then running your tests, a lot of organizations still have manual approvals. Somebody that has to look at data. Now, thankfully, right, we have data available. It could be functional test results, but then the question is this now, this one failing test good enough or not enough to get it back to the next stage? So it needs manual knowledge, obviously, to figure this out. Then we have organizations like you that have invested a lot in automating performance in pipelines. So I know a lot of organizations have already figured out how to automatically execute tests as part of the pipeline, performance tests, whether it's JMeter, Neolog, Gatling, LoadRun. I'm sure there's many tools out there. Yet I think still one piece of the puzzle that is not completely solved yet is this build really better than the other, but just by looking at metrics, at graphs that we can also pull into your DevOps pipeline. And the last part, and Bert, this is also what you said earlier, you've been investing in APM for many years now as a consulting organization, right? And APM is great, but it sometimes gives you too much data, right? What do you do with all this data? Again, whether it's from Dynatrace or whether it's from Prometheus or any other monitoring tool, it's great, but often it is unstructured and it's not linked with the actual test and the build. And therefore it takes even more time to really come to a good conclusion. And this is really the problem that we want to solve. We want to make this more automated. Now, the inspiration on how to solve this problem came actually on the one side from Google's SRE practice, So I assume a lot of you attendees out there are familiar with it, but let me just recap for those that don't know. We'll talk a lot today about service level indicators. These are SLIs. Basically what it is a measurable metric, like the error rate of, let's say, the login request in case we execute tests against login. Then we are having SLOs, so our objectives. Our objective is, for instance, that a particular SLI has a certain value over a certain period of time, typically used in production monitoring, where you can say login error rate must be less than 2% over a 30 period of time, a period of, 30-day period. And then we have SLAs, and I think the difference between SLOs and SLAs are that SLAs are typically then also binding to some business objectives. That means, hey, if logins are not reliable and fast enough, that means, for instance, if my login is not meeting up to my expectations 99% out of a 30-day window, then we have a problem. We may get penalized, we may have customers drop off. These are SLAs. There's a great video out there on the Google Cloud YouTube video channel, so please check it out. It's called SLIs, SLOs, SLAs, oh my, it's really great. The top, again, I borrowed this from one of their decks, SLIs drive SLOs, which informs SLAs. But here's the point. This is a practice that has been heavily used and is used in production, because we always talk about a certain period in time in production. Now, this is where the second inspiration comes from. How can we use this in pre-prod? And this inspiration comes from our Thomas Steinmaurer and his team, where what they've done at Dynatrace for the last couple of years, every time they deploy a new build into the continuous performance environment, they do something very similar. So what they actually do, they figure out, is this build better than the other? And the way they do it, they are pulling out individual metrics, SLIs. So they're looking at different things that they know are important, memory consumption, throughput, IO, whatever it is. They have objectives for every SLI. An objective could either be a hard-coded SLI where they say it should not consume more than 5 GB on the heap after we run these tests, or it could be something, it should not be worse than the last release build. And then they're looking at all the values across and basically say, based on all the SLOs across all the SLIs, we consider this a good or a bad build, and they call this the performance signature. And this is what has kind of inspired us to build the Keptn Quality Gate capability, which also uses an SLI SLO-based evaluation approach. And I know, Bert, we will see this later from you. That's why I keep it short. But in order to use Keptn Quality Gates, you need to define SLIs, what metrics, what indicators are important for you, give it a logical name and a query. And the query depends on the monitoring tool or whatever tool that delivers that value. And I think today we're going to see Dynatrace. So it's a Dynatrace metric query, indicators. Then you specify your SLOs. What are your objectives? You can define different thresholds for pass and warning criteria for every SLI. You can also specify different weights. You can also make one SLI a key criteria, and then you specify an overall score. Now what happens is, when you call Keptn, please start my evaluation for a particular time period, in our cases will be the time period of the test, of my, let's say, my service that was under test or my test environment, and here's my SLI and my SLO, then Keptn automates that process of pulling out all these indicators, the values from the underlying tool, compares them against your SLO, scores every metric, and then comes up with an overall score. So it could be you achieved 7 out of 8, or you just achieved 5 out of 8, and therefore that's the total score, and then the total score depends whether you made it or whether you didn't make it. A more thorough example is, again, because we want to see how this works also across builds. If you have different SLIs, like in this case, response time, failure rate, response time of my login transaction, number of database calls of my login transaction, this is all data that comes out from, let's say, modern monitoring tools. Then you can specify your SLOs on top of it, whether static or relative thresholds, and you specify an overall score of the whole evaluation. Then you can call Keptn with every build. Let's say with build 1, you just deployed it, you ran a test for a couple of minutes. Keptn can do the evaluation for you and returns a score. And 100% looks pretty good to me. That's why we can then let the build pipeline go through. If build number 2 comes along and something kind of falls over, you can always decide, is this still good enough? It's in the warning range. Yeah, maybe we still let it pass through, or we inform somebody that something is not right and then do a manual promotion. Build number 3, in this case, it seems that the response time and failure rate there was the problem in build number 2 is fixed the screen again, but now they introduced the regression in the login transaction. The number of database calls jumped from 3 to 6, which is not allowed, and the response time jumped from 90 to 120 milliseconds, violating our SLO. And therefore, we're getting penalized, and therefore, we only get 62.5%. Build 4 comes along, everything is fixed. And the idea is if we can automatically integrate this in every build and we get automated fast feedback, this will have a change in how developers will actually work, because you get fast feedback and you can immediately see what impact you have and you can faster fix things. This is how it looks like in PowerPoint. This is how it looks like in the Keptn's Bridge. I know Bert is going to show us more live demo anyway with a heat map and a chart visualization. But the point is, if we take Keptn and our approach, then we can level up our pipelines by integrating these quality gates. The first thing, and Bert, this is what we have to solve anyway, when you run a test, we have this concept of tagging. So we need to tell the monitoring tool who is picking up metrics that these metrics come in from a particular test. We call this tagging. And then it's about, instead of having somebody manually look there, you say, Keptn, here's my SLI, here's my SLO, you go off, you do your evaluation, and then you report it back. And then this should be much faster. Now, having this said, it was a quick intro in the problem that we want to solve. And now, Bert, I want to hand it over to you. So let me stop sharing on my end. Yep. You should be able to share now.
Let me share my entire screen. And let's jump directly. Let's wait a minute until this controls things go away.
Yeah, I know sometimes this is a little bit. Hey, and Bert, maybe one last thing for people that just joined. If you have questions, please put them into the Q&A feature. I see there's questions coming in, like Vikash was asking, the build comparison chart that displays builds and SLOs. This is part of the Keptn Bridge. Correct. It's part of the Keptn Bridge. And the nice thing is you can also display it anywhere, because the data underneath can be also retrieved through a REST call, so you can also visualize that response anywhere. But a reminder, please ask questions.
Yes. So okay, what you see here is our Azure DevOps environment, where we have one of our projects which we constantly are working on, which is called KBI in Dutch, so KBI or something like that. And we actually execute load tests on 2 environments in the same pipeline. So at this moment, it's not included in the complete pipeline from going from one to another, but it's scheduled. So they run daily at noon, and apparently they will start running now, because I'm going to create a release. So that's in the near future. We can look what happens. So let me jump into the pipeline itself, or what we've built. So later on we will do the Keptn part, but actually let's now see in practice what we have in the pipeline itself. So like Andy said, we have the first thing was the tagging. That's done via our JMeter scripts themselves. So we actually use BlazeMeter to run our JMeter script here. So that's an important part. Then all this before is to prepare some data, some test data. So we always execute the same scenarios, but on new data. So we first freshly generate data, then we launch the test, and in the end, we actually wait for the result. Now, when we look at this, you might see that the first thing we actually do is prepare the Keptn environment. And as you've seen, it's a nice little new task with an icon, and that's actually the thing that I've built. So if you want to start with that, if you have an Azure DevOps and you say, okay, let's do the same thing here, you can in this demo live follow along and just type in Google Azure DevOps Marketplace. Type in Keptn, and you can start using it. So this is actually the integration which I've built and which will continue to evolve. But that's actually it. Small but useful. So going back to the pipeline, so this was task number 1, being prepare the Keptn environment, where we actually define our endpoint. It's just something that we select because it's an endpoint which you can manage, where you just say, this is my, my URL and my Keptn token, and that's about it. Then you define the project, the service, and the stage. Probably you're all familiar with it. It will put these things as variables on the rest of the pipeline, but it will also look for if they already exist, and if they don't exist, it will create it. So actually, you don't need to configure anything yet in Keptn. You just need a Keptn installation, and that's it. You can then also define your type of monitoring, Dynatrace or Prometheus. And actually, every time in this step, the SLI file and the SLO file, which you actually provide and which are also in the code base, of course, are pushed to Keptn as well. So the add resource is also done.
That's pretty cool. So to kind of quickly to recap, so what you've done here, the only thing you really need is you need to connect your Azure DevOps, or you need to provide the endpoint configuration of Keptn. And then what you are doing through the API calls, you say, Keptn, I want to make sure that this project exists with this stage and for this service, and then you create it in case it's not existing yet. So you completely automate the configuration. Yeah. Then you also do the enable the Dynatrace monitoring for that particular project, because this is something, and maybe there was a question that I just answered. I think it was from Vikash. One of the reasons why you may not see data in the bridge for your quality gate is that either you have not uploaded your SLI and SLO. The other thing could be that you have not enabled your monitoring tool for that project. And this is something you automate here. Yeah. Cool.
So all these steps, which in the beginning, of course, I also did manual, is now something that can completely be automated as well. So adding new pipelines in a traditional pipeline way, like in Azure DevOps, is just a matter of setting up these tasks. I've made it kind of, I use 3 tasks. I could do it in one, made 3 tasks because I see a lot of potential with in the future also, because Keptn is event-based, of course, and you need to send an event to Keptn. So once BlazeMeter has done his job, the next thing is, by the way, I also push an annotation to Dynatrace, which we will talk about later. I also send afterwards an evaluation, the start evaluation event to Keptn. So these things are not yet implemented. That's on the planning of the near future. So what do you need to pass with your evaluation event? Your start time and your end time in a specific format. And these are actually filled in using via this script. So this script already gives me the start time and the end time of BlazeMeter. And it's also not the start time of the pipeline itself. It's really the one that BlazeMeter says I started then, because sometimes it can take a while before BlazeMeter scheduled actually its load test. And then in the end, you actually have this step being, okay, wait for the results. This actually waits until the evaluation done event comes in, and it gives me, and there's not a lot of configuration here, but it gives me a pass or a fail. It will put the pipeline in orange or in green or blue. I don't know what the colors are. Mm-hmm. So when we take a look at our current pipeline, still running. BlazeMeter takes about 5-6 minutes. Then it will go further. Maybe I can also already show. I don't know if this one gives me a lot of log, except that yes, it's using this endpoint, and this project already exists. And yes, I've added these files. Mm-hmm. So maybe I can jump into the.
Maybe one quick question, Bert, because this just came in. In case the project does not exist, you basically create a new Keptn project with a simple shipyard that only contains a single stage
Yes,
because
correct.
the main use case here is a quality gate. So we basically say, Keptn, I need this project that has a single stage that is called whatever it's called, and then you're adding a service. And the service, I think this is also something I learned over the last couple of weeks, doesn't necessarily have to be just one microservice. It can be the name of the app that you're testing, right? Because we also see actually you have some pretty cool stuff done in your example.
Yeah. I mean, this project, we started with this in 2010, and that says a lot because it's a monolith. We're on the track of breaking it down, but you need to have a business case of breaking down a monolith. So at this moment, this KBE project is still far from your typical Kubernetes running cloud native application. But we use the quality gates, and we do bi-weekly deploys, so that's all good. So when I go to my repository to actually show what is in our files, so basically you see that I've got two test stages. Actually, they're both the same test script. Running on two environments, where in one environment we have some more early adopter features, and on the other it's more the one that goes immediate to production. So the scripts are the same, but the functionality of the application itself is a bit different. So that means that we have defined the same SLI. So this SLI file is used for both these projects. I made them two projects, and you see that this is not the, maybe I can enlarge a bit. This is not your typical SLI file which you find in the examples. The first 5 are, and then you have the second one, and then this one, because we have a monolithic application, so we do load tests on the front end, or mimicking the front end, and we actually have our front end going to our back end, going to our database, so it's the entire thing. And therefore, I'm not only interested in the response time and the throughput and the error rate of my front end, I'm also interested in what does my back end do, because there can be some chattiness between those things, and the response times here also are a bit different than the ones there. And also the database. So I'm also interested in especially the throughput of the database specifically. So these selectors, it's the Dynatrace language. I'm using the typical Keptn project, Keptn stage tag, and then some specific tags which we have. So our web nodes, our RMI, and our database specific things.
So Bert, this is really cool, because I was just asked another question similar to this. So that means that's a perfect example here of combining metrics across an architecture. And the way you have gone about is you are putting obviously the Keptn stage tag on it in Dynatrace. Yep. So you can reuse that, and also the project. But then the third tag is a tag that you put on your web node, on your RMI node, your SOA node actually, and and then your database.
And the database. Yeah. These tags were already there. So we're using Dynatrace longer than we use Keptn. So these tags were already there. So it was a natural choice for me. I think I have even included now the Keptn service. But that's all going to be the same for all of these things. Like you said, the service is just a container in Keptn if you use the quality gates. So, but our SLOs are a bit different. First reason is for me to play around. And then the other is that indeed our AC2 environment can have some other things specified, because you have potentially newer functionalities in here than on the ACC environment. So yeah, we've defined for most of these, and not all, for a couple, the specific requirements which we want to. So for example, the database throughput should not go above the 5% compared with the 5 previous successful runs. So let me go back and zoom in or zoom out a bit to pipeline again. The second one is going along. So this one ran, and it's good because it failed. That's part of the show. So first of all, my blaze meter test also failed because I have 3 real failures. So that's one thing. And then this result and gave me a Keptn context, and my score is only 60. Shame on me, and we have a failure there.
This also may answers the question right earlier. I know you're going to show us the bridge soon, but that means the data, the individual results also come back to you, to Azure DevOps, so you could potentially visualize whatever you want, and you decided to write it out as a log file.
Yeah, it's we come later to all the improvements which we have in mind, not planned but in mind. Anyway, this is I think it gives the flow which you just showed us rather well. So look at Keptn. Yes, we can look at Keptn to actually see what it did there. But let me first show Dynatrace, because I also created a dashboard here where I can follow up the difference, the load tests of the AC2 environment and the ACC environment. And I actually have here my response time by JMeter steps. So that's that first part, the tagging part. So what we actually have done in our JMeter script. I'm unprepared. It's not open yet. Whatever.
It's real life.
It's a real life. So this is actually our JMeter script, and we've added, or we pass along some headers as well. So your execution path. So this integration for the headers actually make sure that we have these things tagged, so we know that it was executed by JMeter actually. But we have a lot more things which are actually added by BlazeMeter. So BlazeMeter still has an old Atmon integration feature, and it adds actually also headers to the steps. So, and then by configuring the request attributes, we actually know this was coming from a test, and it was coming from this test step. So all the things you see here, I know there's not a lot of other activity going on at this hour, but all the other things you see here and here, those things are actually the results from the test itself. So it doesn't take care of any other request which was going on at that time by a user or something. Voila. Maybe something else. When we click through in Dynatrace, we also see the events here. So you see these annotations. So BlazeMeter, this actually were one from this noon, and one here. So this one was just pushed. So this one came from the pipeline itself. So that's directly done, not via Keptn, but directly from in the pipeline. I have a nice link to the results of what BlazeMeter reports us. And normally there should also be, voila, the quality gates. This one was actually sent by Keptn, and nice. And we have even a CI backlink, so I can jump back to, okay, what was executing this. and a forward link to Keptn to actually give me the results and why did it fail at this point. So
and this is also great. Just to let, so that means your Azure DevOps to Keptn integration is also pushing that quality gate result to Dynatrace, including a lot of additional metadata, like the link back to Azure DevOps,
yep.
but also the link to the bridge, which is one of the questions they would ask. You can actually generate all of these direct links to an individual result into the Keptn's bridge, because we have smart links and you
yep.
can. Yeah.
This is what we're using here. You
exactly.
See, actually,
and
this is
and also in Keptn, right? We see that you have the labels up there.
Yep.
The labels, these are also things that Azure DevOps is passing on to Keptn. So on both sides, you know what is actually happening. Yeah, that's really cool.
Yeah, it's the ultimate integration, everything pointing to each other. Shouldn't be afraid of links.
Yeah.
It was invented a while ago, hyperlinks, but it's quite useful. So a few other things. I think we're there.
There's a question. Let me just quickly go. Can you do me a favor? Can you go back to the bridge again?
Yep.
So because the question came in, how is the weighting? How does this work? How is the SLO calculated? And by default, right? If you look at the heat map here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. How many do you have?
A lot. It always grows.
Yeah, it grows. So basically, we look at those SLIs where you actually have a criteria. You can see some of those, web throughput and the RMI error rate, they are showing up as white. This is no criteria. You just get the raw values. As you said earlier, Matt, you may not know the criteria yet. You may just want to learn, and I think that's why you can get the raw data. And if you click on chart on the top, if you switch over to the chart, right, then we can obviously look at some of these metrics over time, right? If you click on them in the legend, DB error rate, they will, I think, is one of those, and then maybe maybe some others, right? You can just unclick score and then click a couple of those. Yeah, exactly, right. So that's great. So you can actually get the historical data. So that's one thing. Now, if you do me a favor, click back to the heat map, because the question was how is the weighting and how is this calculated? So in this case, if you look at the last build, the one on the very right, we have 1, 2, 3, 4, 5 SLIs that are producing a value. 4 of them are orange, 1 of them is green. That means by default, every metric has the same weight of 1. So everyone is contributing the same amount of points to the total score. The total score is 100. So, and if we have 1, 2, 3, 4, 5, that means every SLI can potentially contribute either 20 points if it's green, 10 points if it's orange, or 0 points if it is red. And the question was, how can you change the weight? And you can change that weight if you do me a favor and go back to your SLI document.
The SLI, yep.
Yeah. Sorry, the SLO, not the SLI.
The SLO.
Exactly.
I didn't define weights, but yeah.
Yeah, but you can, right? Maybe you don't have to save it, but if you do me a favor, go into one of these and just add,
for example,
maybe after error rate, just add a new line in line number 10. Just add a new line, and then you can say weight and colon, let's say 2. Then this gets twice as much weight as the others, because by default everyone is 1. And I think there's also another key element here that people are not aware of. I think that's the key SLI. So instead of weight, you can also say the web error rate is very important to me. And if that fails, the whole build should fail. And then you can add a new line. You can say, I think it's called key-SLI, and then true or false. We have to look at the spec exactly, but I think it's key SLI. In this case, if web error rate fails, the whole evaluation is considered as fail. Right? That also gives you a lot of freedom.
Nice. Yep. So yeah, very valuable for us. Let me jump back to the, or forward to the slides. So this is just a recap, the place where you can find it and download it, the current version. So we have our 3 tasks, which actually handle all the communication between Azure DevOps and Keptn, and then the Keptn system does what it does. So indeed, you see that it's at the wait for evaluation. At this moment, in Azure DevOps, you can say fail or fail with warnings. I just say fail with warnings always. So even if it's failed or a warning in Keptn, but that's something which is planned to change and to actually make it configurable, so that you can decide what to do with it, and also maybe get some more details of the result. And then the result is indeed the heat map in Keptn, and the fact that you don't have to look for it. I just added here also for the people who are interested, the YAML configurations, but it's just the same. So here, like already said, in the prepare, we actually prepare and just call the APIs, and what does it result in? The result in Keptn, in the configuration of Keptn, it just pushes the SLI and the SLO to the right folder. So that's it. While we launch the test, actually indeed the mark evaluation, and then trigger the test. And he also said that each SLI will be transformed and pulled. I think I've shown you the tags, which are actually transformed to whatever service that you actually or service projects and so on stage. So it actually gets from the SLI provider the metrics, then does the magic, which is not that magical, in fact, because Andy just explained how it all works with the weight and all that. And the only thing we need to do is just wait for the evaluation done. A lot faster than manually, even with a great thing like Dynatrace. You don't want to look at dashboards to manually all do that. Yeah, okay. And in the end, of course, the Keptn itself also sends the results if you have the Dynatrace integration back to Dynatrace to your components which have those tags. So that's all nicely integrated. I think okay. So you can find the code in GitHub. You can find the deployable artifacts on the marketplace. Free to use, free to contribute. Just to make it very foolproof, install it, configure it, and you're done. Voila. What's next? So actually, I'm not that familiar with it yet, but we're going to work on it anyway. The idea is to make that final step that we're waiting for, make it a gate in Azure DevOps, release gate. So you have something like gates to actually go from one step to another. The nice thing is you can put your own delay in there. How long should it wait before you send out a call to, and it will free up your resources in Azure DevOps, because that a gate runs on the Azure DevOps server and not on the pipeline itself, not on your agents, because that's also one of the things or the challenges with load tests. Load tests, they take some time, and when you put them in a pipeline, your pipeline is actively waiting for it, so you're actually consuming resources of your pipeline, while actually or locking resources from your pipeline, while in our case it's done in the cloud. It's done by BlazeMeter, so it's just waiting and hanging around. So that's one of the next things that I want to focus on is actually this thing is already there, the Blaze meter service, and they already called it, made it for me, but it's still empty. So the idea is when that Blaze meter is also triggered from within Keptn itself, so that from Azure DevOps we can just say, okay, deployment finished event done, and that Keptn actually is responsible for triggering the tests. Sending the stuff to Blaze meter, and then afterwards do the evaluation, and that we have a quality gate actually in the this is how it's done actually in the pipeline itself. So yeah.
So I mean, this is actually something that, you know, in the discussion we had yesterday, it opened my eyes, because right now what your pipeline does, you have a pipeline that has to basically wait on a pipeline agent, and then you're calling a script that talks to Blaze meter, and that agent then waits until the load test is done. Yep. So you're basically blocking that resource. And then the next thing you do, you say, now Keptn, please evaluate, and then you're waiting again about, I think it only takes 1 to 2 minutes, but still. Now with this approach, now first of all, thanks that Keptn is event driven, you can say you have your Azure DevOps release pipeline that simply deploys and does the deployment. And then at the end you say, Keptn, you go off, the deployment is finished, here's my URL. And then Keptn does all the things, and then you basically just define the final thing that you're expecting as a release gate, which means you're completely decoupling the work from Azure DevOps with something out there is working, that's Keptn, is executing the test, is running the quality gates, and then you just use it as a release gate in Azure DevOps. That's pretty cool. Yeah.
That's the idea. Stop the actively waiting, actually.
Exactly. Yeah. So Bert, there's a couple of more questions that just came in. Your current wait for evaluation done tasks, how long does it wait until the evaluation is done, done event is received?
First I wait 1 minute, and I think I do that, or 1 minute or 10 seconds, and then I repeat that for 12 times. So it's 2 minutes maximum at this moment. Yeah. So in the future that will also be, when it's a gate, that will also be fixed, so that you can configure it yourself. But 2 minutes is more than enough, because it only needs to wait for the metrics, to get the metrics and to do the magic. So that's quite okay waiting for
Exactly. Cool. The next question is, you said you're building Blaze meter support. How about load runner for automated test triggering?
Yeah, I will put it on my list.
But I think to answer the question in general, right? Keptn is an event-driven control plane, which means what Keptn really does, when it needs to execute a test, it sends an event. And in your case, you are going to build a Blaze meter service that is listening to that event from Keptn and is then executing Blaze meter. With Keptn,
it will be. I mean, I didn't actually. I already did it. Huh? I already did that integration to Blaze meter in that PowerShell script which I showed, and it's just sending off a. Actually, it's. I just take the JMeter script and put it somewhere. So it's actually calling some APIs from Blaze meter, and that's it.
Yeah.
So that's the only thing which this service will do. Listen for an event, send some API calls, and done.
Exactly. But the good news is, to answer the question about load runner, that means anybody can write just a load runner service that can then trigger load runner. We had Neoload. They already built their integration for Neoload. Now there's also a generic executor service where you can specify either a shell script or an HTTP request, and then you can already trigger any type of shell script you have, or I think it's bash script or any type of HTTP request. So if I'm not that familiar with the automation API of load runner, but if you have a way to execute load runner remotely from a shell script or an HTTP call, then you can already do this through the generic execution plugin that we have. Yeah. That's also good. The other thing is, let me read this out loud. It really is full automated, because I see that it runs processes manually. Will an orchestrator like Bamboo or Jenkins or another Azure service be missing? Rodrigo, maybe you can rephrase the question. I think you
because I launched it manually. Yeah, normally normally it's triggered at noon automatically.
Okay.
But now for the demo, I need to show something.
Yeah, exactly. Yeah. Perfect. Good. Well, can you do me a quick favor? I think there's one more slide in the end that we put in there, if I'm not mistaken. One or two. So for those of you that are online still, it would be great if we can get your support. Star us on GitHub, do a shout out for us on social media, join the Slack channel. And actually there's an easier way of joining the Slack channel. It's slack.keptn.sh. And also try out the tutorials, provide feedback, feel free to contribute, right? We need more people like Bert who contribute, but really give us feedback. That would be great. And I would say, can you do me, exactly this one here. So if you want to reach out to us, then, you have our names, and there's definitely more coming from us. There's more of these webinars. There's also the Keptn developer focus community webinars that are always, or meetings that are always every Thursday. So in case you want to get in touch with the development team, you want to see what they are doing, you want to influence the backlog, you want to contribute, you want to take issues on, then Thursday is the best day for you, the afternoon. Cool. Bert.
Okay.
Thank you so much.
You're welcome.
And we'll hopefully see you soon.
Yep, for sure.
Thank you. Thanks everyone. Thanks for the question.